can get started. Vidur, we have never met, but I'm glad for that you were able to take time out and talk to us. For others, Vidur runs Mahajan Imaging, which is a chain of high-end medical imaging centers in North India. And recently, he has been very active on LinkedIn. Apparently, he has been taking pictures with a lot of luminaries of the field and sharing it on LinkedIn.
Okay, Abhishek, I'm taking a screenshot. Yeah, I get the picture. One sec.
Yeah, thank you. I would rather that it would be just with me, but it's okay. Like, you know, you can include it. He also runs CARING, which is a Center for Advanced Research on Imaging, Neuroscience, and Genomics. The mandate of CARING is to bring cutting-edge products in AI space to clinical practice. Again, a area which is very active, and we need more initiatives like CARING. As for his training, he's trained in MBA with dual majors in finance and healthcare from Wharton. And we have had a chance to interact with Vidur as well, where, for those of you have kept up, right, around 6 months back or maybe longer, we were trying to pursue this premium data play where we would, acquire data from Mahajan labs and organizations like that and bring it to customers that would benefit from such data. That's something that we are still interested in, but that was the context in which we interacted and learned about Vidur. But I'm glad that you could take time out to talk to us. I'll stop and the floor is yours. Thanks, Vidur.
Thanks, Abhishek. That is quite detailed.
So hi Vidur. So actually we have framed a few questions for you, just to know your journey and your ideas. So to start with, I would like to ask you that what drove you to venture into the integration of AI in imaging? And what do you think is the scope of this market right now?
It's almost like an interview. So I'll try to not give very serious answers first and foremost, because that's just the way I am. So guys, essentially to add to what Abhishek was saying, I think that intro is a little dated. I don't do any of that anymore. Since January 1st, I've been running a startup that we were incubating within Mahajan Imaging called CARPL. CARPL is the caring analytics platform. So this was essentially a software platform that we created that allows any healthcare provider to integrate any kind of medical imaging AI algorithm into their workflows, right? And that's essentially, and why we're doing that is essentially the answer to Jeet's question. So if you, and feel free to stop me and ask me, if I use any lingo that you guys can't understand, or if there's any thoughts that you have. I think this is super informal. So essentially, if you look at this whole world of AI in radiology, right? So radiology is essentially a glorified Photoshop, right? You walk in, people use extremely expensive cameras to click pictures of you, and then extremely well-trained people look at those pictures and try to tell you what's wrong with you, right? It could be an MRI, a CT, an ultrasound, an X-ray, a gamma camera, PET CT, whatever. And the premise of AI in radiology is that there's a limited number of radiologists. It takes 15 years to make one. They are human beings, so they make mistakes. They get tired, so on and so forth. And can AI come in and start taking over some of these tasks? Now, the problem with AI approach to this is that AI is only good in narrow domains, right? So people are building companies. I'm sure you would have heard of CARPL.ai is, one of the well-known companies from India. Then there's Lunit from Korea, Occipit from Lithuania. There's 400 such companies. All of them are building extremely niche AI solutions for radiology. So somebody is building head, CT, stroke, right? Stroke is basically like a brain attack, heart attack types. Or somebody else is building lung, CT, cancer. or liver, CT, cancer, so on and so forth. So companies are building extremely niche solutions. Hospitals don't want niche solutions. Hospitals want all-encompassing solutions, because they're like, what will I do with just a lung, CT, cancer solution? I have 10,000 other things to treat also, right? So that's where we come in and create this integrated, almost marketplace of sorts, where through us a hospital can interface with multiple different AI companies. And the motivation behind doing this, to finally answer Jeet's question, is that nobody else is doing it. I'm sure much of the work you guys do at Elucidata is also driven by that motivation, where you think that something is extremely obvious and someone should be doing it, but nobody else is doing it. Nobody else understands it. Nobody gets the domain. And that's where we were. Yeah. So at Mahajan Imaging, we were trying really hard to use these solutions, but we couldn't, because they were point solutions. And that's why the medical imaging industry today is not, AI industry is not as mature as it should be, because nobody's using this stuff. So that was the logic. So that's where we start taking these algorithms from bench to clinic, in that sense. And another way of understanding it is, I've been trying to explain what we do to a lot of people who don't exactly understand what we're doing. So one analogy I use is that, let's say all of you would be having, I don't know, at least 25 apps on your phone, right? Imagine for a second a parallel reality where instead of having 25 different apps on one phone, you had 25 different phones, one for each app, right? In that reality, you would assume that the apps are useless, because no one would actually be using those apps. Like, you would not have one phone just for Angry Birds, for example, or one phone. Okay, maybe Instagram still you would have one phone, but maybe not one phone for chess. So I can see all the Insta celebrities smiling. So, right. So the point is that having an aggregated platform in the form of an app store uh, allows you to derive value to an extent that you can't otherwise. So that's why we are doing this. That we don't see anybody else making such progress. And of course, then we want to save lives and all that, obviously. But the primary motivation is that we don't see anybody else figuring this out.
So, Vidur, so if we want to know that some pressing issues right now in the healthcare and life science industry that can benefit from this technology, some real life issues, some real cases that can be used to solve using medical imaging AI.
All it's like, what can you do with a doctor, right? If you suddenly had unlimited supply of doctors, what would happen? Right. So if you suddenly have unlimited supply of doctors, cost would fall. You would suddenly have no need for queuing to see a doctor. Access would increase, exponentially. Real life example is of tuberculosis, for example. So WHO last year came out with this guideline saying that it is now allowed that X-ray can be used for screening of tuberculosis without a human being looking at the X-ray, right? So using machine learning algorithms, AI algorithms, you can now screen for TB. You can figure out if a patient or a person has TB or not, without involving a human being. Now, what does that do? That enables any patient anywhere to become independent of a healthcare provider in at least figuring out whether they have TB or not. The same thing. So the way to think about this, guys, and I'm a big fan of frameworks, and please keep asking me stuff also, but is to think about the world of pathology and lab medicine, which is actually closer to what you guys do. I don't know if you've ever been to a path lab, you'll see that there are hardly any people there. Most of the work is done by machines, right? And one doctor signs out 5,000 reports. So they have essentially taken the doctor out of the equation. The doctor's job is quality management as opposed to patient management. And then that's how now you have 1mg.com offering, 100 rupee blood tests that were earlier for 1,000 rupees. So that democratization is only possible if these AI solutions come into the realm. And obviously, once there's democratization, then the current rich poor divide that's there globally in terms of who gets access to what type of care is taken away, starting with diagnostics, right? So that's like the philosophical answer.
So taking from here, so if we can solve some issues using AI, then in that case, what are the key challenges in solving the problem of accuracy and quality in bringing this AI into medical imaging?
Yes, so the Achilles heel of AI today is that AI makes crazy mistakes. I don't know how many machine learning engineers in this group of 93 people. None.
There are plenty.
Plenty, na. So ठीक है, फिर तो I put my life at risk when I say that deep learning doesn't work. Right? It's essentially it's curve fitting or whatever, right? So the Achilles heel of AI today is that we don't know when the AI will make a crazy mistake. So one example, the way I make people understand is that we know of AI systems that will pick up cancer on a chest X-ray that is less than 1 centimeter in size, right? Amazing performance. Like sub-centimetric masses or nodules will be picked up. That same AI will miss a 5 centimeter mass, right? Because it thinks that 5 centimeter mass is a pacemaker. Pacemaker is the thing that runs the heart in case, you know. So those kind of mistakes are made by deep learning, right? Just today I was doing a validation for an algorithm and I saw that it was taking air under the armpit and thinking that that is an abnormality, right? And flagging that as an abnormality. Now these are things that are, you know, architectural issues with convolutional neural nets, right? And the solution to this, in our view, is combining multiple AI systems. So what if I could take 3 AI systems from 3 different companies that do the exact same thing, right? There are competitors, right? There's multiple competitors in this domain. What if I could take all 3 and run all 3 on patient data? And then when all 3 say the same thing, then the chances that all 3 have made the same crazy mistake are close to zero, or essentially zero. So that's what we are trying to do to address it. So that is one challenge, that AI makes crazy mistakes, thereby mandating human oversight today, thereby making it very incrementally beneficial for people to be able to use AI. The second challenge is, how do you get these into hospitals? Have you guys ever tried selling anything to a hospital at Elucidata? Have you?
Yeah.
You have, right? So it takes 12 months, right? At least Western hospitals. So if you have a 9 to 15 month sales cycle for one AI system, and then you have to deploy 20 AI systems to derive value, so it will take 20 years, right? Man years, woman years. So uh, so that's the second challenge. How do we even get these solutions into hospitals? So of course, that's the problem we are trying to solve with our platform. And then the third problem is, okay, let's say I'm able to get these solutions in. How do I retrain? How do I make sure that the AI system doesn't make the same mistake again? Okay, I might have a certain bit of fault tolerance built in, so I can actually uh, cater to a mistake made once. But then when that same 5 centimeter mass is being missed again and again, it's like a very bad student, right, who's doing the same mistake again and again. So these are some of the, they are technical challenges. There are also ethical challenges, right? Like, how do you get data, who takes responsibility? I think all of them can be solved once AI starts generating value. But today the value proposition is extremely niche, and we are trying very hard to expand this value proposition by combining multiple AI systems together, and seeing how that works. But this is one of the key detriments here today.
So, Vidur, who are the key stakeholders right now, and how do customers typically interact with your product right now?
So we at CARPL, we have, I'm assuming you're asking for CARPL only. At CARPL, we have three types of stakeholders. So if you think of it right, we are a marketplace. We have AI companies on one side. We have healthcare providers on the other side. We take AI from this AI ecosystem into healthcare providers. Right now, easier said than done. But these are two stakeholders. One is our supplier, companies that are building AI. Second is our user or buyer, companies that are using AI. In the middle, we have this huge layer of stakeholders, which we politely call them health tech companies, right? Which are essentially companies that provide either software or hardware to healthcare providers and through whom we have to integrate into their system. So integration is basically, when you go to a hospital, you will, typically see a doctor having a screen in front of them, and that screen is running some kind of software. Now, how do you go into that software? You need that software's help. You need the, whoever systems integration specialist of that software to say, okay, yes, we will integrate with CARPL. So that's how, so those are our three stakeholders. Of course, we also invert the equation. We also allow hospitals to monetize back their data and domain expertise to this AI ecosystem, right? Which is just a fancy way of saying that we help them run clinical trials for AI. So that's how we try to, invert the system. But essentially, these are the three stakeholders. And what was the second part? How do they interact with our system? So that's very interesting here, because that also depends on layers, right? There is at the hospital, there is one doctor or doctor IT specialist kind of person who orchestrates the deployment of the AI, who basically makes the purchase decision that my team is going to use these two AIs for chest X-ray, this AI for knee X-ray, this one for brain MRI, this one for spine MRI, like that. So there's one user of ours who's a power user who interacts with our platform and on a day-to-day basis is figuring stuff out. Then the other is a passive user, right? The actual doctor to whom outputs of the AI are just being served. So that doctor can basically determine whether he or she want to implement the outputs of the AI into their workflow. Simple. So those are the two guys. It's a little detailed into how exactly it is that they interact. Like it's through these third-party softwares. We are basically a window within these third-party softwares, and then they interact with us through that. But broadly, these are the three stakeholders that we have. So we think of ourselves as a network, right? We don't think of ourselves as a SaaS business. In fact, we have this saying that we are WhatsApp, not Slack, right? So as our number of user grows, the inherent value of the platform to each user grows, as opposed to Slack, right? Where there can be 1,000 organizations on Slack or 100 organizations on Slack. It really doesn't matter. To me, my organization is what matters. So that's how we think of ourselves. So as this ecosystem grows on both dimensions, the inherent value of the ecosystem to each player also increases. So that's how we think about it. Sorry, too much gyan.
So you recently worked on the application of generative adversarial networks in medical imaging. So how do you see these GANs and other technologies shaping the future of medical imaging?
First, you tell me, why is this question here?
We can skip it.
Did somebody have a specific question on this, or is it just like a general one? Because then I'll appropriately answer, right? Ajit, do you know?
No. So the second part of the question, that how do you see the emerging technologies shaping the future?
No, GAN. So I can talk about GANs. GANs are. Do you guys know what GANs are? Like nowadays, so these generative algorithms, DALI, etc., are so famous, right? You write a statement, it will create a image and all. Are you guys familiar with that? Like, if you are not, you should have one session just going through. There's this Twitter page called Weird DALI Generations, You should just look at that. One sec, I will actually share my screen. That will be more entertaining than.
You have a random pages full of it.
Yeah, that's been going on for a few weeks now.
But Vidur, like our interest in GAN is mostly from generative aspect of textual data.
Of textual data. Okay, so the work that we did, sorry, I've actually found it. There's a demon Gorgon from Stranger Things holding a basketball. So if anybody is interested, uh, so basically our work on GANs was on this crazy aspect of GANs where we were trying to either insert or remove pathologies into chest x-rays, right? So the idea was, can I take a seemingly normal chest x-ray, right, let's say of Vidur Mahajan, and can I give Vidur Mahajan lung cancer? Or the other way around, right? Vidur Mahajan's chest x-ray has lung cancer, can I remove it automatically without using Photoshop, right? So that was the application of cycle GANs that we used. And it was from pure play security perspective, right? Imagine the implications. Tomorrow, the president of a country goes for a scan, an X-ray scan. The X-ray is fitted with some kind of AI, right? We are all talking about AI. So X-ray is fitted with some kind of AI. Within that AI is malicious code that is trained to remove lung cancer. So the president of the country gets an X-ray done. There is truly lung cancer there. The lung cancer is removed by the AI and the X-ray comes out looking exactly like it would for that one person, except it doesn't have cancer. So that person will die because you don't treat that lung cancer. So we approached GANs from a very security oriented perspective, right? To see that what if tomorrow people start creating adversarial or malicious GAN code and start inserting that in as a, you know, virus or whatever into X-ray machines or CT machines, MRI machines, how can we detect that? So that was our intention of using GANs. Of course, there is the more widely used application of GANs, which is you don't have enough training data, you generate training data, right? I think that's been used in genomics as well. And I think in genomics, people are also saying, you know, can you go from 50x depth to 500x depth, you know, super resolution kind of applications. I don't know, like NVIDIA had, I think, done some work on it. But from in our domain of imaging, there's two applications. The wider application is create data when you don't have it. Second, crazier application is remove or insert diseases at will.
So the field of AI in medical imaging, how has the field advanced in the past decade?
The past decade, yeah, we went from AI will replace doctors to now saying doctors who use AI will replace those who don't. So I think it went like this in terms of expectations, and then came here and is now, you know, the whole Gartner's hype cycle funda. So I think that's where it's gone. Its full potential, I think, will take at least another 5, 7, 10 years. One, because of the limitations that I said, right? First, neural networks need to make lesser mistakes, lesser unexplainable mistakes, right? Lesser crazy mistakes. And this is also solved, like we are doing some work on out of distribution detection, where can you actually get an AI system to say, I don't know, right? As opposed to forcefully giving an answer every time you ask it a question. Second is hospitals are generally very slow to adopt technology unless they make shit ton of money using it, which is probably not going to be the case immediately with AI. So that entire 9 to 15 month sales cycle is something that we have to live through, right? And because of that, things are going to be a little slow. But my personal view is that unless and until AI enables radiologists to report at least 10x more scans than they currently do, we would not be doing justice to the technology, right? Like itna AI and all that, and no exponential improvement in productivity is just going to be a failure of our industry. So that's the way I think about it.
So the last one question. So which roles do you feel were the most challenging and which were the most fulfilling for you?
Which roles were to nahi yaar? Things are just starting. So I can talk about which roles are most challenging. But in my past life, when I was running Mahajan Imaging, I realized that the most challenging role is actually of a construction person, right? If you can build a building in India, you can do anything. At least that's my view. That's why I've taken on this bigger challenge now. But no, but honestly, I think just providing healthcare or being in any kind of services business, right? Not having the, and I say this with a lot of respect, but not having the privilege of opening a laptop and starting work, closing a laptop and stopping work is a reality of healthcare that everyone in healthcare should experience, right? I think it's very, very essential. And that is one of the toughest things for our new recruits to kind of understand, that the image that we get, the data that we get is a person. It could be my mother, it could be my aunt, it could be my brother, it could be my kid, right? So how do you make your team respect the data in the way you would respect your family member is on a philosophical note, one of the biggest challenges that we face in the industry today, because it's not data, it's a person, right? Second, just being able to explain what we do to people is very difficult. Like, I'm certain many of you also haven't got it. Every day I also understand it more. But yeah, like, trying to solve, and I'm sure like at Elucidata also, you guys, I'm certain you can't describe in one sentence what is it that you do, right, to a routine person. So that's difficult. What else is difficult? Building in India, selling to the world is something we should all take pride in. It's very difficult, but I think that's a common thread that ties our companies. That we are taking the smartest people in our country, making them, I think, stay in the country. And selling to the entire world. I think it takes a lot of effort, but it's hugely fulfilling. So I can keep going on and on and on gyan here. So feel free to stop me.
So Vidur, I guess there may be a few questions from the participants. So I'll please request the questions from anybody.
Just take the question from chat. Prashant has been the question.
Oh, sorry.
So the first question I see is, so are these algorithms assisting doctors in detecting diseases or reducing their work, like taking the diagnosis?
No, so it's a spectrum, right? Like, it will, obviously you have to detect disease to reduce work. But the way we think about it is, there is the efficiency improvement side of AI, and then there is the quality improvement side of AI. Quality improvement makes you better, efficiency improvement makes you faster or more productive. And there are AI applications for all of that, right? And the broad framework we use for that is that in imaging AI, there are 3 steps. There is image acquisition, which is the process of clicking the picture, right? You can make that process faster, you can make those images better, you can make the process more seamless. That is one. Second, after that is this space of post processing, where typically a human would do some process. It is not still creating the diagnosis, but it is doing some process that leads to creation of a diagnosis, like measuring the volume of the liver, for example, right? Or measuring the volume of a brain tumor, or measuring the volume of pneumothorax in the lungs, or whatever, right? Some volumetric measurement, some non-diagnostic thing. So segmentation, for example, right? So that's the second piece, and that makes people obviously faster, lesser effort is put in. And then the third is around diagnosis, where again there are two steps. AI can do things that humans do, which is essentially make the same diagnosis that a human can, right? So for example, pneumonia on a chest X-ray, TB on a chest X-ray, like that. And the second is, which is crazy, is AI doing things that humans can't do, which is, for example, predict the onset of breast cancer before it has actually happened by looking at a mammography scan, right? Which is something humans just cannot do. Like, we can't, right? How will I look at a normal scan and predict that there's breast cancer? So that's the, like, the 1 minute answer to that question. Of course, like, this is a 1 hour discussion in itself, but yeah.
Vidur, actually, I have one question. So, because these images depend on the body shape and body pattern and bone density, so it's a major struggle to get images from Indian population. So, how are you and your company solving this?
So yeah, it's not a major challenge to get data from anywhere. In fact, not just India, whether it's US, Europe, Brazil, Australia, Singapore, India, wherever. But the basic tenet of life applies, and that the tea is only as sweet as the sugar you put in it, right? So if you invest money, you can get any kind of data that you want. If you expect the data to walk up to you and say, hey, take me, I am a truly diversified data set across all demographics, across all age groups, etc., that doesn't happen, right? So I think it's a myth that data is difficult to obtain. The reality is data is expensive to obtain, right? So if one is willing to put in, so for example, right, we work with some of the biggest device companies in the world, and their data requests go down to, okay, I want uh, let's say 1,000 x-rays of age range 20 to 25, 25 to 30, 30 to 35, 50% male, 50% female. 5% of the scan should be ICU, 5% of the scan should be ICU with an endotracheal tube, 5% of the scan should be endotracheal tube plus Ryle's tube, so on and so forth, right? And then across BMI also. So that's where it's very easily solved with money here, the data question. There are now data marketplaces there also, which are available, where you can go. SegMed, for example, out of Stanford, is one such startup that basically you go there, you search, you buy data. So that very much exists. I'm seeing a couple of questions on the chat. A philosophical question: will this lead to more lazy doctors or heavily dependent on technology doctors? So I don't know what the correlation between lazy and heavily dependent on technology is. If there is correlation between that, then yes, it will lead to lazier doctors. The way I would think about it is in terms of flying aeroplanes, right? A pilot without autopilot is a tired pilot, or is a pilot with autopilot a lazy pilot? Rhetorical question, right? So certainly heavily dependent on technology in the future, and they should be, right? Otherwise, why should there be such a big delta between a good doctor and a bad doctor, right? There shouldn't be. Technology should act as that neutralization or normalization function. So Richa, I hope that answers your question. Shashank, what do you think of Mimic CXR? Mimic CXR is this open source, freely available chest X-ray data set. It's amazing. Every bacha in India is building an X-ray model off of data from Mass General and Beth Israel, which is extremely sad, but it is what it is. So Mimic chest X-ray is amazing. They even have reports. You can do NLP analysis on it. They even have the biochemical parameters. You can do all sorts of multimodal analysis on it. So I think it's amazing. We need to have our own Desi Mimic chest X-ray. So Shashank, I hope that helps. Nilanjan, is the marketplace going to integrate AI services for biomolecular data as well? Yes. So what possibilities are there? I think once we get to multimodal data, yes, then. But today, with the imaging, whose non-AI use cases are so widely established, faces such a difficulty in establishing AI-based use cases. I think in bioinformatics or biomolecular data, even the non-AI clinical use cases are emerging, right? So how will we integrate that? Although we did, like when I started caring, like G was genomics, I was imaging, N was neuroscience. Neuroscience was supposed to be the linker between the two and all that. But for now, I think bioinformatics is and biomolecular data is more maybe the domain of pharma and lesser on the clinical side. I'm not saying not on the clinical side, but lesser. What's your approach to the relationship between use of technology to diagnose patients versus to do research to advance the medical field? Oh, great question. It would seem that working heavily in the latter will help to gain experience, trust, and traction of the former. Correct. But we have to draw a line, Richard, somewhere, right? Like, we can't just keep doing research, and keep publishing papers all the time. And because if you look at our world of imaging AI, like, you would believe if you just looked at the research, you would think it's a solved problem, right? That there is enough AI. AI is better than doctors. Doctors should, quit. In reality, you go to any hospital anywhere in the world and you ask them how much AI they are using, the answer will be a big fat zero, right? And that's, because of the issues that, so I think the time has come to push for translational research, right? How do we do research not on neural networks, that will continue, but on economic value of neural networks, right? We need a lot more economists, a lot more business people doing research now on AI in order to figure out where the value is. Is it with insurance companies? Is it with providers? Is it with patients? Where is it? Who will pay for it, right? So that's what I think about this. How do you deal with X-ray machine hardware challenges? Challenges in the sense, Prashant, can you like turn your speaker on, sorry, mic on and elaborate? Yeah.
Sure. So like at least in like the developing part of the world, not all the images are digitized, right? And that's one part of the problem. And the second part is like there are different machines, different resolutions, different images that they give out. So
Correct.
how do you deal with those challenges?
Correct. So and it's essentially like a non-digital image is a type of different format that is, if we consider that paradigm, that different X-ray machines produce different types of resolution, size, contrast, etc. of images, and a photo of a manual image is a type of that image. Yeah, you just have to train different networks for different images. That's our view right now. Or you match them to a template. But our clinical view is that whatever you do, you first test retrospectively, right? So no matter what the algorithm, first figure out of the total cohort that you intend to run through the AI, is the your target cohort actually being catered to well by the AI or not. And that can only be done by pre-deployment validation, right? Where you set the boundaries that, okay, do not use this AI on an X-ray that is tilted more than 15 degrees, for example. Why? Because I have tested it on 1 degree, 2 degree, 3 degree, 4 degree, 5 degree. And like that, I've come to this, insight. So that's what we, push for right now, is pre-deployment validation. And of course, then you have to do it every month to check for drift and shift and, all those things. I've been to your lab in Delhi. Interiors look nothing like traditional diagnostic lab, rather look like cute bohemian cafe. What was the thought process here? AI designed it, of course. And didn't give an explanation because there's no explainable AI.
No, I think I was actually very surprised when I came to your lab, and I think I told you then as well. It's just not like you would imagine a hospital or a diagnostic lab to look with, very dark blue colors that you typically think of. At least that's the image that I have in my head. So I would love to know, like, What led you to design it in the way it was? I've never seen a lab like that.
So first and foremost, like the idea is very simple. Yeah, you don't need to make patients feel like patients, right? Already poor guy is in pain, and then you put them in a white room filled with white stuff and white coats and all that. So it's just a matter of challenging the status quo and trying to give people an experience that you would want, right? Simple. I think it's just, and we have the autonomy to be able to do it because as Prashant has said, we literally have our name on the board, so we can do whatever the f we want. And one of those things is painting the ceiling blue, or like putting paintings all over, or doing whatever it is. So it's more it's more like, why does a Taj look like a Taj and Oyo rooms look like an Oyo rooms, right? At the end of the day, you are spending the night in both places. But नील तो काफी रहा है Oyo room में, ऐसा लग रहा है smile देख के. So that's the true answer. Yeah, there's no business logic to it. It ends up costing not a lot more, a little bit more, because our return cycles, so again, that's a very different business, right? Return cycles are 10 to 12 years. In 10 to 12 years, 10% more cost means like nothing. So that's the logic there.
So Vidur, thanks for the interview, and I just pass to AJ for the thank note.
Thanks, Dave. I think there's one more question from Shashank.
Do you consider design while making software for doctors? Oh my God, should I give you a demo? Chalo, de dete hain demo. I'll give you 30 seconds demo. Prashant has asked, definitely. Chalo, very good. I'll give you one sec. Why can't I share my entire screen?
Devika would not let you. Right, Devika?
No, please try now.
Interesting. I can't. Anyways, I'll figure it out. Can you see the weird Dali?
Yes.
Okay. So this is what our software looks like. We actually got a game designer to design our software. So this is our dashboard. This is our AI algorithm menu, right? These are all commercially available and open source AI algorithms from different companies across the world. This is our notification bar. This is our stick figure using which you can navigate different body parts and different AI solutions for each body part, so on and so forth. If you're an academic center, you can add your own AI algorithm. So yeah, certainly, I don't know how much design, but prettiness for sure is a factor that we consider. And considering that in an organization of 300 doctors, maybe we'll have one user for this platform. I think it's a little bit of overkill, but then, I like showing off. So I am also Punjabi. So then, this is our statistical analysis, AUC values, ROC curves, sensitivity, specificity, whatever threshold. You can change the threshold, change the sensitivity. You can do deep dive into false positives, false negatives. This is our DICOM viewer, which we had once upon a time thought we will integrate with your platform, and so on and so forth, right? So we have workflow tools, blah blah blah. This is what like ensembling of commercially available AI algorithms looks like, so on and so forth, right? So I'll not show off more, but basically, yes, we consider design. We basically try to do things we like here. I think it's a simple thing. How did you move from being a doctor to doing an MBA to heading a startup? Head, though I don't think I do, but doctor I became because my dad wanted me to be an engineer and I couldn't do what he wanted me to do, genuinely. Then while doing the doctorate, I realized I should have been an engineer only. So at the end of medicine, I was getting radiology residency, but one day before that, I gave a presentation to my dad saying that, you know, if I switch to the business side of things, maybe I can uh, have more impact. So he was like, do whatever the F you want. Then I joined the management side of our business, started growing that, opened imaging centers, etc. Then realized very quickly that जीत तुमने PhD कर लिया है ना?
Yes, yes.
हाँ ठीक है. So we realized very quickly that nobody respects an MBBS doctor. Nor does, like, the medical community certainly doesn't, and management community obviously doesn't. So no, but jokes apart, the reason I thought of doing an MBA was because I had not seen any other company in my life, right? I had only seen our family business. That was the only P&L I had seen, only balance sheet, only customer I had ever seen was our own. So decided to do an MBA, decided to not do from India because I thought that I already had the India network, so I should go abroad, blah, blah. Also, it would have been fun. So managed to go to UPenn for that. And then providentially, things happen here. I at UPenn in 2015 went to Israel, saw this company called Zebra Medical, which was amongst the first medical imaging AI startups, realized very quickly that AI is the future. Came back to India, started building Mahajan Imaging again. This time started carrying the research division because I liked it. Had a team, had a problem. Everybody was building AI, nobody was using it. Had the arrogance to believe that we'll be the only ones to be able to solve it, and continue to have the arrogance and not much more. So that's like the super fast version of my story.